This is the seventh and final section of Module 3. In this section, we will discuss linear inequalities and related word problems. To review, an inequality is a statement that contains one of the following symbols: less than, greater than, less than or equal to, or greater than or equal to, in that order. Below you see some comparisons between equations and inequalities. In equations, we compare two expressions using an equal sign. In inequalities, we compare two expressions using one of these inequality symbols. One important part of solving linear inequalities is being able to graph the solution. These are the steps we will use when we graph the solution to a linear inequality. First, we want to use a number line. Secondly, we used a closed circle at the endpoint of an interval if we want to include the point. We will know to include the point if we have one of these symbols: greater than or equal to, or less than or equal to. Use an open circle at the endpoint if you do not want to include the point. So if we have one of these inequality symbols instead, greater than or less than. And below you see some examples of what it looks like when we use a closed circle or an open circle. Sometimes we will also have to graph a compound inequality, which means we have more than one inequality symbol. So the way we would read this expression, -2 is less than x, which is less than or equal to 5. Essentially, x represents all of the values between -2 and 5. So let's look at this in two pieces. On the left side, we're using an inequality symbol that does not contain the equal to sign. And for that reason, we are using an open circle. The open circle always corresponds to one of the inequality symbols that does not include the equal to symbol. Now on the other side, on the right side of our compound inequality, we have x is less than or equal to 5. And so it's okay for x to equal 5 because we have the or equal to option since we use this particular inequality symbol. For that reason, we are using a closed circle at 5. Now because x represents all of the values between -2 and 5, including 5, all of the values between 5 and -2 have been shaded. When we deal with inequalities, there are many similar properties as those we saw when we were dealing with equations. We have the addition property of inequalities, which basically says we can add or subtract the same value on both sides of the inequality symbol and have an equivalent inequality. We also have the multiplication property of inequalities. And the only difference between the multiplication property of inequalities and the multiplication property of equations is if we multiply or divide by a negative number, the inequality symbol will flip. It will reverse directions. And so if we started with a less than symbol, it would become a greater than symbol. This only depends on multiplying or dividing by a negative. It has nothing to do with the solution to the inequality. Here are the steps you will use to solve linear inequalities. The steps will look very similar to those steps that we used when we were solving equations. First, if we have fractions or decimals, we can multiply by the LCD to eliminate those fractions, or multiply by a power of 10 to eliminate the decimals. Then steps 2 and 3 basically say we need to simplify each side of the inequality by distributing and combining like terms. Step 4 says we need to isolate the variable, so move all the variables to one side of the inequality, preferably the left-hand side, all the numbers to the other side using the addition property. And then step 5, we get the variable completely by itself without a numerical coefficient other than 1 by using the multiplication property. So let's try a few examples. 5x minus 7 is less than 4x minus 9. And once we solve the inequality, we want to graph the solution set. So we look at each side of the inequality. and there's no simplification that needs to be done. There are no like terms, there are no parentheses. So now we want to move all of our variables to the left side, all of our numbers to the right side. So we subtract 4x from each side of the inequality. The opposite 4x's cancel on the right-hand side. We're left with negative 9. 5x minus 4x is x, so we have x minus 7 is less than negative 9. At this point, we will add 7 to both sides of the inequality. The opposite 7's cancel, so we're left with x on the left-hand side, and x is less than negative 9 plus 7 is negative 2. Now let's note two things. Number one, we're using a symbol that does not include an equal to sign. So we're going to have an open circle at the value. We have an open circle at negative 2. We can also use the inequality symbol to tell us which direction we need to shade. Think of it as an arrowhead that's pointing in the direction that your shaded line is going to go. So this arrowhead is pointing to the left, so we will shade every value to the left of negative 2. And that would be the graphed solution set. X is less than negative 2 would be the inequality notation that we would put into the original solution. Here's another example. Negative 9x is less than or equal to 27. And then after finding the inequality notation, we would graph the solution set. So here, we look at both sides of the inequality, and there's no simplification that can be done. All of the x's are on one side of the equation. All of the numbers are on the other side of the equation. So we only need to divide by the coefficient. So we divide both sides by negative 9. The negative 9's cancel, and we have x. Now remember, whenever we divide by a negative, our sign reverses directions. So instead of less than or equal to, we now have greater than or equal to. 27 divided by negative 9 is negative 3. Because we're using a symbol that has the equal to included, so greater than or equal to, we will have a closed circle at the value. So we have a closed circle at negative 3. And just like in the last example, using our inequality symbol, somewhat like an arrow, we know we should shade to the right. The number is greater than negative 3. So every number to the right of negative 3 would be shaded all the way to the end and forever. Here's another example, and this example gives many people problems on homework, on tests, during the videos, so make sure you pay special attention to what's going on. Negative z is greater than 0. We want to solve this inequality and graph the solution set. The first thing I would do is rewrite this as negative 1 times z is greater than 0. Sometimes if we don't see the coefficient, especially if it's negative, then it's easy to make mistakes. So we need to solve for z. Right now we need to eliminate this negative 1 that we're multiplying by. So we divide both sides by negative 1. The negative 1's cancel on the left-hand side. We're left with z. Remember, when we divide by a negative, the sign reverses direction. So instead of greater than, we have less than. Z is less than. 0 divided by negative 1 is 0. So this is the solved inequality notation. Because we are not using an inequality symbol that includes the equal to, we're going to use an open circle. So we have an open circle at 0. We use our inequality symbol to tell us which direction to shade. So we treat it like an arrowhead. We're going to shade to the left, which makes sense. The left, those are the numbers that are less than 0. Let's try an example where x starts out on the right-hand side of the inequality. So we have negative 6 is less than x plus 9. Now one thing we could do to solve this inequality in one step is subtract 9 from both sides of the inequality. If we did that, the opposite 9s would cancel, and we would be left with x on the right side, negative 15 on the left side, and the inequality would still be facing the same direction. So negative 15 is less than x. If we leave it in this form, where x is on the right-hand side of the inequality, it is very easy to make a mistake when graphing. So let's change sides. We're going to write x on the left-hand side, negative 15 on the right-hand side. Well, if negative 15 was less than x, that means x is greater than negative 15. If we reverse the sides, then we have to reverse the sign as well. We write it this way so that when we go to graph, we can use our arrow trick and know that we should shade numbers to the right of negative 15. And so let's put negative 15 somewhere on our graph. Why don't we call this 0 somewhere near the middle, negative 15 on the left side. We put an open circle at negative 15 because we're using greater than, not greater than or equal to. We would shade all numbers to the right of negative 15. Here's another example where we will have to simplify each side of the inequality. We have parentheses, so we will need to distribute and then possibly combine like terms. So we start by distributing the 2 to the x and to the 7. That gives us 2x plus 14 minus 14 is greater than, on the other side of the equation, we distribute the negative 4 to the x and to the negative 7, which gives negative 4x plus 28 plus 8. Now we need to combine like terms. On the left side, we have 14 minus 14. On the right side, we have 28 plus 8. Combining like terms gives us 2x is greater than negative 4x plus 36. Now let's move all of our variables to the left-hand side. Plus 4x plus 4x. The opposite 4x's cancel on the right-hand side. On the left-hand side, 2x plus 4x is 6x. So we have 6x is greater than 36. We now divide both sides by 6. The 6's on the left-hand side cancel. We have x is greater than 36 divided by 6 is 6. So because we're using the symbol greater than and not greater than or equal to, we'll have an open circle at 6. We use our arrow trick, which tells us and indicates we need to shade to the right. The number is greater than 6. Now, just like when we had equations with fractions, we can solve inequalities with fractions by first eliminating the fractions. To do that, we need to find the least common denominator. In this case, the least common denominator of 4 and 15 would be 60. Once we find the least common denominator, we multiply both sides of the equation. So we would have, well, in this case, we would multiply both sides of the inequality. We would have 60, we can write this as a fraction, 60 over 1 times 1/4 times x minus 9 is less than 60 over 1 times 1 over 15 times 4x minus 1. We would multiply the two fractions, 60 over 1 and 1 over 4. That would give us 60 over 4 times x minus 9 is less than 60 over 15 times 4x minus 1. 60 divided by 4 is 15, so this becomes 15 times x minus 9 is less than 60 divided by 15 is 4. So 4 times 4x minus 1. We now distribute the 15 and distribute the 4. 15 times x is 15x minus 15 times 9 is 135. That is less than 4 times 4x is 16x. 4 times negative 1 is minus 4. Let's move all of our x's to the left side and numbers to the right side. So we subtract 16x from each side of the inequality. The opposite 16x's cancel on the right side. On the left side, 15x minus 16x is negative x. We also have minus 135 is less than negative 4. Let's get some more room here. So negative x minus 135 is less than negative 4. And let's add 135 to both sides of the inequality. The opposite 135's cancel. Negative x is less than negative 4 plus 135 is 131. We're not finished because we don't have a positive x. We want x to be by itself, no numerical coefficients, and that includes negative 1. Remember, negative x is the same as negative 1 times x. So negative 1 times x is less than 131. We divide both sides by negative 1. Negative 1's cancel on the left-hand side. So we have x. The sign reverses direction because we divided by a negative. And the right-hand side becomes negative 131. Now, for this particular example, we don't need to graph the solution. Now let's try a few applications of solving linear inequalities. So here it says Ben bowled 130 and 181 in his first 2 games. What must he bowl in his 3rd game to have an average of at least 180? So if you're not familiar or you don't remember how to find an average, we take the number of scores and divide the total of each game added together. So we have 3 scores. Or we want 3 scores. The first score was 130. The second score was 181. And the third score was unknown. And it says we want to have an average of at least. And so we don't want it to be any lower than 180. So the average should be greater than or equal to 180. We can simplify a little bit in the numerator on the left-hand side. We take 130 plus 181. We can't add x because it's not a like term. So we have 311 plus x, all divided by 3, is greater than or equal to 180. Now, just like we've seen in the past, when we have one fraction in the problem, we can eliminate that fraction by multiplying both sides by its denominator. Now, on the left-hand side, when we multiply and divide by the same number, those numbers cancel, and we're left with just the numerator. 311 plus x is greater than or equal to 180 times 3. It should give us 540. Now, at this point, all we need to do is isolate x. We do that by subtracting 311 from both sides. So if we subtract 311 from both sides, the opposite 311s cancel on the left-hand side, leaving us with just x. So x is greater than or equal to 229. So Ben must bowl at least a 229 or something higher than that in order to have an average of at least 180. Let's try one more example that you might see in the homework. It says William and Deborah are celebrating their 20th anniversary by having a reception at a local reception hall. They have budgeted $2,500 for their reception. And now it tells us the price, what the charge for each person in the cleanup. So the reception hall charges $60 cleanup fee plus $39 per person. So find the greatest number of people that they may invite and still stay within their budget. So essentially, we need an inequality that looks like this. The cost must be less than or equal to their budget. Let's go through the problem and circle the mathematical operators, box the numbers that are important, and underline the unknown value. So as we go through, we see that we have the word per. That's a mathematical operator. Plus, that's a mathematical operator. They want to stay within their budget. That tells us that the cost has to be less than or equal to the budget. Let's also box some of the important numbers. We have $2,500, that's their budget. We have the $39, and we talked about $39 per person. We have a $60 cleanup fee. And now, let's underline the value we're actually trying to find. We want to find the greatest number of people that they may invite. So we're trying to find the people, the number of persons they can actually invite, and in doing so, stay within their budget. So let's look at the cost. And let's add all the things that will cost money. We have a $60 cleanup fee plus $39 per, remember that means multiplication in this sense, per person. And isn't that what we're trying to find, the number of people? So 39 times X. So that would be the total cost. And that needs to be less than or equal to the budgeted amount, $2,500. So let's see what we can do here. Let's first rewrite this as 60 plus 39x is less than or equal to 2,500. Now to start solving for x, all the x's are already together, so we just need to move the numbers to the other side. So we start by subtracting 60. On the left-hand side, the opposite 60s cancel. We're left with 39x is less than or equal to 2,440. Now at this point, in order to solve for x, we would divide by its coefficient. So we go to the top where we have some more room. Now we divide both sides by 39. That gives us x is less than or equal to 62.564, and so on. Well, we all know that we can't invite 62.5 people, but x must remain lower than that. X is less than or equal to. And so to stay within budget, we can only invite at maximum 62 people. We cannot round up to 63. Typically we would. If this wasn't an application problem, if this was just an equation we were solving, we might round up to 63. But if we go up to 63, it would cost too much money. We would not be able to stay within budget. So we round down. And typically when we talk about financial problems, budget problems, we are going to round down so that we don't spend too much money.